Today we'll be working on lesson 4.2 nth roots, and we're going to be working on the practice sheet trying to simplify nth roots. So what are nth roots? So far we've been working with square roots and trying to simplify something like this, okay? But today we're going to be working with cubic roots. For example, the cubic root of 8, which is a 2. And we're going to learn also how to simplify 4th roots, 5th roots, and so on. So that is the aim of the tutorial today, how to simplify different nth roots. In this video I'm going to be working on the even numbers on the 4.2 practice sheet. So let's go on to number 2. Square root of 16 x to the 4th y to the 6th. Now remember, every time you have a radical, we call this the radicand, and we call the number on the little number on the outside of the radical to be the index. Now since this is a square root, we know that the little number on the outside is going to be a 2, since this is a square root, so the index is 2. Okay? And to simplify something like this, you have to think of each part under the radical separately. So let's think of the square root of 16. Now you all know that the square root of 16 is 4, since 4 times 4 is 16. And let's think of the square root of x to the 4th. Now you can think of this in a couple ways. One way could be, since I know that the index is 2, I can look at the power of the variable, which is a 4, and the index. As you can see that the power is completely divisible by the index. So you can say that the square root of x to the 4th, and you can change that into x to the power 4 divided by 2. So 4 divided by 2 is x to the 2nd. So the square root of x to the 4th is completely simplified into x to the 2nd. Now y to the 6th, square root of y to the 6th, you can do the same method, which is basically dividing the power by the index. So 6 over 2 is completely simplified into 3. So the answer of square root of 16x to the 4th, y to the 6th is going to be 4x to the 2nd, y to the 3rd. Remember, square root of 16 is 4. To simplify x to the 4th, 4 divided by 2 is a 2, and 6 divided by 2 is a 3, and this is how you simplify radicals. Now why we can do that? Now there is a different method to solve something like that if you don't want to divide the power by the index. And I'm going to show you on the side over here. If you have square root of 16 x to the 4th, y to the 6th. Now I want you to know that you can do this method, which is like x to the 4th, which means that I have x times x times x times x, 4 x's as you can see. Now since the index is 2, it means anything groups of 2 will leave the radicals. So I have a pair and a second pair. So I have, from this group x is going to leave, from this group x is going to leave. So I have x times x leaving the radical, and that's x to the 2nd. And as you can see, we got the same answer. Now y to the 6th, it means I have y times y times y, and so on. Okay, since the index on the outside is 2, then I know that anything groups of 2 will be leaving the radical. So that's a pair, that's a second pair, that's a third pair. So that means then y to the 3rd is going to leave the radical. This is another method to do it. So then the answer would be directly 4x to the 2nd, y to the 3rd. Now you can do any method that you like, but I feel that this is faster, easier, more efficient. Now let's move on to number 4. Now let's move on to number 4. Negative square root of 16x to the 2nd, y to the 10th. Now you can do the same method of simplifying. Now you can think of the number on its own first. Square root of 16 is a 4, and remember you had a negative in front of the radical, so copy it down. And square root of 16 is a 4. Now since this is a square root, so the little number or the index on the outside of the radical is a 2. Now x to the 2nd, let's simplify that. The power divided by the index is a 1. It's completely simplified to x to the 1st. Now y to the 10th power, the power is completely divisible by the index 2, so y to the power 10 over 2, so that's a 5. So my final answer is going to be negative 4xy to the 5th. As you can see, everything is simplified, so that's your final answer. Now let's move on to number 6. Okay? 6th root of 64, x to the 9th, y to the 13th. Now, 64, we all know that basically it's 6 2's multiplied together, so it's 2 to the 6th power. So what you can do is instead of the 64, you can write 2 to the 6th, x to the 9th, y to the 13th. So first of all, I'm trying to simplify the 64 first. Now, as you can see, there is one group of 6 2's. So that means I have one group, so only 1 2 will be leaving the radical. Now, this is one way to think about it. So only 1 2 will be leaving the radical. Or what you can do is instead of the 64, you can write 2 to the 6th and apply the same method as dividing the power by the index. 6 divided by 6 is 1. So you know that only 2 to the 1st will be leaving the radical. So you can do this method, or you can write it out and see, since the index is 6, so I want groups of 6. So I have only one group of 6, so 2 to the 1st will be leaving the radical. Now, let's look at x to the 9th. Is 9 divisible by 6? No. So you have two methods. You can either take the x to the 9th and write it out, and then since the index is 6, so you need to do groups of 6. So let's see, 1 2 3 4 5 6. So I have one group of 6 x's, so I'm going to write x to the 1st, since I only have one group, so only one x will be leaving the radical. As for these 1 2 3, as you can see, there's no group of of 6 x's, so what you can do is you leave these inside the radical. So 1 2 3, x to the 3rd will be staying inside the radical. Okay, so this is one method to do it. Now another method I'm going to be using for the y. Instead of taking y and writing it out 13 times, which is just painstaking work, what you can do is you can divide the y to the 13 to do different y's having different powers that would add to 13. But you have to think of these powers in a way that one of them would be completely divisible by the index. So for example, let's say that I want to divide 13 into, for example, let's say 8 and 5. Let's see if this was a smart choice. Now 8 plus 5 is 13, right? So I did the dividing of the y 13th correctly, but is the power 8 divisible by the index 6? No. Is the power 5 divisible by the index 6? Also no. So this was not a smart choice. You need to divide the 13 in a way, into two different powers in a way that one of them is divisible by 6. So I think 12 and 1 is a better choice. Let's see. 12 plus 1 is 13. So I did divide y to the 13 properly. Remember, because when you multiply, you add the powers. Now let's look at the powers. Is 12 divisible by 6? Yes, 12 divided by 6 is 2. So that was a smart choice. Now, so I already have a 2 and an x outside. We know that x to the 3rd is not going to leave the radical. Y to the 12th is not going to leave, y is not going to leave the radical. Let me erase that. Okay, so 2x, 6 root of x to the 3rd. Okay, now let's think of the y. The power of this y is 12. 12 divided by 6 is a 2, so I know y to the 2nd is going to leave the power. However, this y has a power of 1. 1 is not divisible by 6, right? So this is going to stay inside the radical. So that is going to be my final answer. Now let's move on to number 8, 4th root of 81. Now, we all know that instead of 81, I can write 3 to the 4th, since 3 times 3 times 3 times 3 is an 81. So you can do the same method as we've been doing before. You can divide the index by the power by the index. So 4 divided by 4 is a 1. And as you can see, it's completely simplified, and the answer of 4th root of 81 is a 3. Okay? Now let's move on to number 10. Cubic root of -8. Now some of you are asking, can I have a negative under the radical? We've been learning that you cannot have a negative under the radical. Yes, if the radical is an even radical. For example, square root of 4 is 2. However, square root of -4 is not possible in the real set, and that's why we learned about I, the complex number. But this is not possible in the real set. Okay? And the reason behind that is whenever you square 2, you get a 4. And whenever you square a -2, you get also a 4. So your answer, whenever you're squaring a negative number, is always positive. So that's why you always have a positive number under the radical. But if the radical is an even radical, for example, 4th root of, for example, 16 would be a 2. And 4th root of -16 would not be possible in the real set. And the reason behind that, again, is every time you raise a negative number to an even power, the answer will always be positive. However, if you cube the 2, you will get an 8. And if you cube a -2, you're going to get a -8, because -2 times -2 is positive 4, times -2 is a -8, right? So it is possible to have a negative answer if you're cubing a negative number. So that's why it's possible to have a negative number under an odd radical. So if you have cubic of a negative number, you know that the answer will be negative. And the cubic root of 8, that's going to be a 2. So your answer is -2. Now let's move on to number 12. Cubic root of 16, x to the 4th, y to the 3rd, z to the 7th. Now remember that 16 is 2 to the 4th, so I'm going to rewrite that. 2 to the 4th, x to the 4th, and so on. Now what I can do is I can split 2 to the 4th into 2 to the 3rd and 2 to the 1st, since 3 plus 1 is 4, and one of the powers is divisible by the index. As you can see, 2 to the 3rd, 3 divided by 3 is a 1, so this is going to leave the radical. 1 is not divisible by the index, so it's going to stay inside the radical. Okay, so I'm going to, let me make this just a little bit smaller so I can fit numbers. Okay, so 3 divided by 3 is a 1. And I have this one staying inside the radical since the power is not divisible by the 3. Now x to the 4th, I can split that into x to the 3rd and x to the 1st, since 3 plus 1 is a 4. Now, power divided by index is 1. So as you can see, this left. This one, the power 1 is not divisible by the index 3, so it's going to stay. Now let's move on to y to the 3rd. Now as you can see, 3 divided by 3 is a 1. So that completely left as well. I didn't have to split it, so because from the beginning the power was directly divisible by the index. Z to the 7th, I can divide it to z to the 6th and z to the 1st. So 6 divided by 3 is a 2. And this is going to completely leave, while this is going to stay, since 1 is not divisible by the index 3. Don't forget, you have to end up with the same type of radical. So my final answer is going to be 2xy z to the 2nd cubic root of 2xz. Now let's move on to the next problem, which is 14. Cubic root of 2 to the 16, 216 p to the 3rd, q to the 9th. Now, we all know that 2 to the 16 is basically 6 times 6 times 6, so it's 6 to the 3rd, p to the 3rd, q to the 9th. Now, this is an easy one since all the powers are divisible by the index. 3 divided by 3 is a 1. So the power of my answer is 1. 3 divided by 3 is a 1. and 9 divided by 3 is a 3. So my answer is 6p q to the third. Now let's move on to number 16. Square root of 75, x to the 7th, y. Now, as you all know, that 75 is basically 15 times 5. So 75 is basically 15 times 5. And 15 is 5 times 3. So we can write 75 as 5 times 5 times 3, which is 5 to the second times 3. So I can rewrite this radical as 5 to the second times 3 times x to the 7th times y. Now, since it's a square root, so the index is 2. And now let's try to simplify. Let's look at the 5 to the second. 2 divided by 2 is 1, so it's going to completely leave the radical. Okay. Now, 3, basically it's 3 to the first. 1 cannot be divided by 2, so it's going to stay inside the radical. I can rewrite x to the 7th as x to the 6th and x to the first. 6 divided by 2 is a 3, so it's going to completely leave the radical. X to the first, 1 cannot be divisible by 2, so it's going to stay inside the radical. Now, as for the y, it's y to the first power. Now, 1 is not divisible by 2, so the y is going to stay inside the radical. So my final answer is going to be 5x to the third square root of 3xy. Now let's move on to number 18. Square root of 50, c to the 8th, d to the 16th. Now 50 is basically 5 times 10, which is in turn 10 is 5 times 2. So I can rewrite 50 as 5 to the second times 2, and I copy the rest. Since this is a square root, so I know the index is 2. Now 2 divided by 2 is a 1, so it's going to leave the radical, this one. 2 is to the power 1, so it's going to stay inside the radical since 1 is not divisible by 2. Now let's move on to 8. As you can see, 8 is divisible by 2 and you get a 4, so this is going to leave the radical. D to the 16, 16 is divisible by 2, 16 divided by 2 is 8, so d to the 8th is going to leave. So my final answer is going to be 5c4, d8, and square root of 2. So that's going to be my final answer. Now let's move on to number 20. Now, square root of 24, x to the second, y to the 14th. Now, so far we've been basically dividing the number into its different prime factorization and using the powers and all of that. But you can still, if you don't like this method, you can still use the prime factorization that we learned earlier. So basically what multiplies to 24? We know that 2 times 12, circle 2. 12, we have 6 and 2, circle 2. 6 is 3 and 2, so circle these. So we know that 24 is basically 2 times 2 times 2 times 3, right? Now, since it's a square root, so I know that the index is 2, so it means anything in groups of 2 will leave the radical, right? So I have one group of 2, so basically one pair. So only 1, 2 will leave the radical. The 2 and the 3 basically are lonely. I don't have a pair of the 2, I don't have a pair of the 3, so both will stay inside the radical. So you can say 2 times 3 is a 6, so 6 stays inside the radical. Now again, you can use the method of dividing the powers, which is very simple, or if you don't feel comfortable, you can still write it down. So x to the second is x times x. Since the index is 2, so anything in pairs will leave the radical, so I have only one pair, so that's why I have x to the first leaving the radical. Y14, I have 14 y's, so you can write y's as many times as you want, and so on, and basically just pair them, and you will see that you will have 7 pairs, and that's why we divide the powers. So 14 divided by 2 is a 7, so it's much easier to do it this way, just divide the power by the index. So the answer is going to be 2xy to the 7th square root of 6, and that would be my final answer. Now I hope this tutorial was helpful. Please go ahead and attempt the odd numbers on your own.